Welcome, everybody. Good morning. My name is Josh Winchell. I'm an assistant research scientist at Texas A&M University's High Performance Research Computing. And today I'm going to introduce you to our ACES cluster, a composable cluster. And we'll talk about what that means briefly in a minute. This is mostly going to be pretty introductory, showing you all how to do supercomputing with our clusters broadly. And I'll, of course, spend some time talking about what's special about ACES as well. Let's go ahead and get going. So here's an outline of the things I want to cover today. Some of the stuff at the end we may not spend much time on. We'll see how much time we have as we get to it. I'm going to start with brief disambiguation because there's a couple words I'm going to say a lot that may need explanation. After that, though, I'll have a brief overview of what ACES is like and where to find more information about it, documentation and whatnot. We're going to try to get you all logged onto the cluster today to start doing some basic exercises. So I'll show you around our Open On Demand portal and show you how to do some basic operations on ACES. I'll talk about how to get software on the cluster to run fancy workloads. I'll talk to you all about Slurm a bit. And then again, those sections at the end, I'll tell you some of the special things on ACES, the special accelerators it has, and how it's set up and whatnot. So first of all, that brief disambiguation. Again, these are words that unfortunately I will probably say a lot, but are easily mixed up with one another. So I want to at least acknowledge them here. First of all, in case you're new to supercomputing broadly, maybe you haven't heard the term HPC. That stands for high performance computing. It means supercomputing, basically. Supercomputing, HPC, it's a broad field. A lot of people do it. Compare that to HPRC. HPRC is specific people. It's people I work for, high performance research computing. HPRC is the HPC Center at Texas A&M University, specifically. If you have been in the field for a while and you think of supercomputing in Texas, you might think of TAC. They're unrelated to us. That's the Texas Advanced Computing Center. That's UT Austin's HPC Center. And we do work with them sometimes, but like we're separate entities, just so you're aware. Final two words, and these are the ones that I'll definitely say a lot, ACES and ACCESS. ACES with one C and one S, that's the name of the particular cluster that we're going to be using today. ACCESS is an NSF program, so nationwide, and that connects a bunch of supercomputers at a bunch of sites. So rather horribly, we're going to be accessing ACES with ACCESS. In our defense, ACES was named at a time when ACCESS was called something else. So it didn't used to be this bad, but it's what we're stuck with now, alas. Okay, let's go ahead and get going. Let's talk about what is interesting about ACES broadly. So what's the motivation here? We say ACES is composable. What is the deal there? Well, your more traditional HPC on the left here is built on converged hardware. It's very static. It's very fixed. That is, you build it, and that's kind of essentially all it is until something, breaks or whatever, and then maybe you reorganize it. We want to move towards something more flexible. Composability really to me means something more flexible, something built on disaggregated hardware and composable or modular hardware, accelerators, memory, stuff like that. This picture here, I think, illustrates it maybe a little bit better. Again, compare the traditional HPC system on the left, or your traditional supercomputer on the left. You have these servers in blue. In this top one, say you put in one GPU and one SSD. This next one is two GPUs and SSD. Third one's two FPGAs and an SSD, etc. The point is, though, once you put all these devices into these boxes, that's kind of it. That's all they're ever going to be. Sure, in theory, if you want to move these around, you could turn off your nodes and physically unplug things and open up the boxes and put them somewhere else. But generally, you're not going to do that. For the most part, this is static. This is not going to change. With a composable cluster, though, on the right, now we have everything hooked up in pools. So we got a server pool, an accelerator pool, and storage and memory pool. All these hooked up to this liquid fabric. Liquid's the name of the company. And through this fabric, we can compose nodes on the fly as we want them. So do you want an FPGA and two SSDs in a node? We can make that happen without physically, plugging in those components to one another directly. We can just ask the software for that, and it'll compose this node for us. We want 4 GPUs in an SSD. Even if that's not something that physically exists, we can compose this node for you. Perhaps you want something that's not even physically possible. You want 14 GPUs in a node, something that you're not going to plug into a literal physical server box. We can still compose that for you through this fabric here. So again, to summarize, what's interesting about composability is both the flexibility to set up something that isn't currently set up, but also to do things that wouldn't normally be easily done or physically possible to set up. I see a question in chat. Will this recording be made available? Yes, we are recording. It will eventually go on our YouTube channel. Okay, Victor got it. Thank you. Yeah. There will be some processing time involved, and I'm afraid I don't know how long that is, but it will eventually be on our YouTube, yes. If you want to see this class before that processing is done, I believe we do have some older versions of this class on the channel already, but this one will show up there eventually, yes. So today we're talking about ACES, our composable cluster. ACES is actually our second composable cluster. We had another one, FASTER. That was the first large-scale composable CPU and GPU system, sort of the precursor to ACES. ACES is the newer, bigger, better thing. And FASTER is no longer available through ACES, so we're just going to stick with ACES today. So what is ACES about? ACES, again, with one C, one S, it's an acronym for Accelerating Computing for Emerging Sciences. Our mission here, it's an NSF, oh gosh, the naming gets worse. So it's an NSF ACES CI testbed. So the cluster is ACES, we access it through ACES, it's funded through this ACES program. Luckily, this last one I'm not going to talk about a lot, so you can just forget that if you want. Point of ACES though, we want to offer an accelerator testbed for numerical simulations and AI ML workloads. And in addition to providing this hardware to enable this type of research, we want to provide consulting, technical guidance, and training to researchers. So we give you the hardware to use, and we're going to help you use it and collaborate with whatever research you're doing. We want to enable you at every step of the way, as much as we can. Okay, now I want to get us on ACES. I'm worried our accounting people might have been busy, though. Let's go ahead and give it a shot, though, and see where they are. The way you're going to get onto ACES, you can start off on our homepage, hprc.tamu.edu. I'm going to go ahead and go there, hprc.tamu.edu. Okay, and I'll just go ahead and put that in chat, too. This is just our homepage. You may have been in our websites already if you found like the course registration page. From any of the HPRC pages, you're going to go up to this portal tab here, and in this dropdown, you're going to go to the ACES portal. On the off chance that some of y'all have access to the other clusters as well, I do recommend you go with ACES today specifically, because some of the examples we have are using software versions that are specifically on ACES. So if we all go on ACES, we'll be sure that the examples work the way we expect them to. Now, when you click that button, depending if you log into Access or not, you may get dropped off on this screen. If you're not logged into Access already, you're going to log into Access. In my case, my identity provider is Texas A&M University. If you set up your Access ID with somebody else, probably your own institution, you'll select them there, or that default option, Access CI. It's possible you set up a password with them, but however you set up your Access ID, use that option and log in. This is going to send. Oh, lovely. My computer wants to restart. I think that'll happen after the course, though. All right, let's ignore that for now. So since I chose Texas A&M to log in, it sends me to Texas A&M single sign-on. You will probably have your own institution's single sign-on or equivalent. And once you're through that, you should end up here. This is the ACES Open On Demand portal. Now I'm going to pause here for a minute. I'd like everybody to try to get to this page. if you're not here already. For today, the plan is to give you access to ACES, so you can follow along with me. Again, I've not seen messages from our accounting people, which is somewhat concerning, but I'm going to pause for a minute. Everybody try to get here. If you have any trouble, let me know. Once you have gotten there, I request you give me this green checkmark reaction in Zoom so that I know you've gotten there. I request that instead of the thumbs up, because the thumbs up goes away by itself, whereas the checkmark has to get cleared. So I'll give y'all a minute, get to that portal page, and let us know if you have any trouble. Question in chat from Demetrios. The access to ACES for today is only for the course. That is correct. The access you have for this right now is going to expire like end of the day or so. If you want to request computing time in the future, I will talk about that. Yeah, if you're at another US university, you can get on ACES for free through Access. You're going to request an Access allocation and then exchange those credits for time on ACES. I'll talk about that in a couple of minutes. I'm going to go ahead and move on. We have a little while before the first exercises though, so if you are still working on it, you still have time. If you get stuck though, send us your Access ID in the chat, and we'll pass it on to our account people and see if they can fix any trouble you're running into. For now though, let's keep going. So before I move on, there's of course a lot of things you can do on ACES, so I want to let y'all know where you can find more information after this course if need be. First of all, there is our HPRC knowledge base. If you have, also you can find it at this link here, hprc.tamu.edu/kb. As well though, if you're on any of our websites, up in the top right, you have these buttons. You can find the knowledge base by clicking on this W button up here. W for wiki, we used to call it the wiki. The knowledge base looks something like this. If you need help on ACES in particular, you want to go to this second tab up here that says user guides. And this is a guide for all of our clusters, but it happens to default to ACES, so that's convenient. These are our other clusters. You may not have access to all of them, so stick with ACES. Quick start guide, overview of the hardware, links for the specific accelerators, the batch system, file system, bunch of stuff here. Again, some of this I'll be covering today, but we don't have time for all of it. So be aware of these pages if you want more details in the future. You may also be interested in these software pages. We got a bunch of pages for a lot of the software that we have on all of our systems. You can find some guidance there. Frequently asked questions for various things. We have information about managing accounts, managing file spaces, etc. So look through this sometime if you need help. Okay. We've mentioned it already, but we have a YouTube channel. Victor shared the link a little bit earlier. As we mentioned, this class is getting recorded. It'll get posted on the YouTube channel eventually, but we do have a lot of other previous short courses posted there already, including general purpose courses like this and a bunch of other like software or domain specific trainings as well. We've got short videos for like basic how-tos, longer short courses, etc. Aside from the link that was shared, you can also find that from our home pages or any of our web pages with the YouTube button up here. And yeah, here's our homepage. We have an ACES specific playlist. We got short videos, long videos, etc. So check it out sometime. Okay. I think where are we at? Okay. On the note of short courses, lastly, again, since I won't have time to cover absolutely everything today, you should be aware of the other courses that we're teaching this semester, including in particular, we have classes dedicated to a couple of the specialized accelerators on ACES. So if you want to use the Intel PVC GPUs, we have a training event for that coming up this semester. We don't have the exact date set, but you can find it on our training pages. Check out this link here. We've also got a dedicated training for the graph core IPUs coming up later this semester. I think the PVCs and IPUs, I think those events are scheduled for March. Though again, that schedule's still kind of up in the air. Oh yes, let me show you. Again, from our web pages, if you want to see the courses that we're planning on teaching this semester, go up to the training menu, and then in the dropdown, go to courses. And this will get updated every so often. But here, for example, is today's course, this afternoon's course. Most of the classes that are scheduled for this month, registration is already open. You can see those here. But then down below those, all of our tentative classes, we've at least got the months shown that we're planning to teach them. Again, these could change, but if you want to get a sense of the things that we're planning on teaching, check out this webpage sometime. So, for example, we do have, PVCs planned for March, and I believe the IPUs as well. Yes, also March. So again, check back on this page every so often. It'll get updated, as the weeks go on and as we get our schedule settled. Okay, so. All right, let's move towards working on the ACES cluster. So first and foremost, before we do things, before you get settled on ACES, be aware of some of the big picture rules. Be a good compute citizen. You have your own personal account. Do not share it. Do not share your account. Do not share your password. Do not share your accounts like personal home areas. Like there's specific ways to collaborate with people, and sharing the stuff that is yours is not the way to do it. So don't do that. Secondly, of course, don't do anything illegal. In particular, be wary of like sharing data overseas or something. Be sure that you're not going to violate the EAR and ITAR laws. And lastly, if you're using commercial software, be sure to abide by all those rules. Please don't make big companies mad at us on our clusters. Okay, so Demetrios asked earlier about how to get on ACES in the future outside of this course. Let's talk about that. The way you're going to do that, sorry, just a moment. Oh, Windows everywhere. Okay, so the way to get on ACES generally, outside of the training course, you're going to request an allocation through either ACES or the Nair pilot. Both of these will get you onto ACES. I'm going to focus mostly on ACES. I think that's the more common option. Broadly, what you're going to do, so following this little image here from ACES, you create an account. You'll have all done that already because you have an ACES ID. Then you're going to select opportunity. That is, you're going to look for, the flow is going to be, you're going to request an allocation of some size, depending on what all needs to happen. If that allocation gets approved, you'll receive access credits. That's like cluster agnostic credits. And then you're going to choose to exchange those credits for time on the clusters. I'll show you more details on the following slides here. So first of all, who can get on ACES? Usually it's going to be a PI who requests an allocation, and then they would bring along researchers with them. So PI has undergraduates and graduate researchers working with them, or not necessarily students, like research scientists as well. The PI would get the allocation, and then they would share that allocation with the people coming along with them. I see a question, Dr. Elahi?
Thank you. I am not very experienced. So in the past, one of my students have done a project. We exchanged our credit for Delta. So why would I choose ACES versus Delta? Can you help me take that point from this talk?
Okay. So yeah, from ACES, you can get onto a lot of supercomputers, Delta, ACES, Jetstream, etc. Which one you choose will depend possibly on like the hardware they have or what software they have. I mean, it depends on what you want to do. So for ACES, the selling points, as I mentioned before, is composability for one. So if you want like a lot of GPUs, if you want that 14 GPU node, only ACES is going to do that. We do also have a bunch of other specialized accelerators. So I mentioned the Intel PVCs, the graph core IPUs. We've got vector engines, FPGAs, next silicon coprocessors. think that's all of them. I have slides at the end for those as well. So why would you get on ACES? It's, do you want that special hardware? And do you think composability would get you the hardware you need more quickly? So yeah, getting on ACES, PI request the allocation, bring people along with them. If you're not a PI, you could also still get your own allocation. For example, graduate students can get their own allocation with a letter of collaboration from their PI, for example, to work on their thesis projects or something. So once, or rather, when you're applying for an allocation, I mentioned there were levels. Access has 4 levels of allocations that you can get. If you're just starting out, you're probably only going to be interested in the lowest 2, but I'll touch on all of them briefly here. The smallest level is the Explore allocation. Again, it's the smallest level. It's also the easiest to get. Like I think you're gonna have to give them like a 2-sentence description of your project and a CV, and that's about it. The Explore level is, per the name, it's meant for exploring a resource, checking to see that it has the resources you need to do what you're working on, check that your workflow can be set up in small scale, etc. I believe you can request an extension to the number of SUs that you get with Explore. So if you do happen to run out of Explore, your first step might to just be request more. I think you can get, it might be a one-time extension. Get Explore allocation to start, try out a relatively small amount, but you can extend it once if you want. If you've established, though, with the Explore that this is definitely the cluster you want to work on and you need more resources, at that point, you might consider bumping up to the Discover level. The Discover level will ask you for a bit more information about the project you're doing. Discover is good for possibly single-person production runs with benchmarking at scale. This also might be the level you work with if you're an educator and you need to get a classroom on the cluster to do a project with you. You would apply as the PI and then share it with your students. Beyond that, you get to the Accelerate level. This is when things start getting big. This is almost certainly in the multiple people category. And then the Maximize level, this is so big it's special. If you're just getting started out, don't worry about that. This is for really big projects with really big goals, etc. Again, if you're just starting out, go with an Explorer. It's relatively easy. It's free. I mean, all these are free. You just got to explain what you're doing and justify why you need this level, etc. So say you've gotten an allocation approved. You've now got a chunk of sort of generic access credits. And those credits you will then choose to convert to time on any given cluster. You can even mix up clusters. So once you have the allocation, your access allocations page will have something like in the screenshot here. It will show you have this many credits, so 200K in this case. And then in this dropdown here, you'll just choose what resource you want. So, could be ACES, could be Delta, could be Jetstream, could be some mix of them. You can split them up however you want. Once you have submitted this form here, then whatever site you have put in here, they'll get notified that you want to work on their cluster, and they'll take some time to activate your account. And once they notify you that you're ready, then you can go ahead and log in. So let's say we're through all that, and let's start doing things on ACES. We're going to start slow. I want to tell y'all about the ACES portal. So working on ACES, there's 3 layers of computers, to my mind, that you should be aware of. First of all, you have your own machine, of course. Your goal, though, is to get off your own machine. Maybe you've been doing research on your personal laptop and it's just not big enough. Now working on ACES, it's just going to be the terminal. You're going to be using it to send commands. It's not going to be doing any work itself. You're going to use your computer to log into the second layer, which is the cluster's login nodes. Excuse me. The cluster has 2 sets of nodes, login and compute nodes. You're going to start off on the login nodes. The login nodes are small. Per the name, they're mostly for logging in. You're just going to write small instructions here and then send those instructions off to the third layer of computers, the compute nodes. And I'll talk about how to write those instructions and manage them later. The compute nodes, that's where all the big supercomputing actually happens. That's where you're going to be spending those access credits that you converted to time on the cluster. And again, we'll talk more about how to manage those jobs and expenditures a little bit later. First of all, let's talk about what we have in the portal. So hopefully everybody who's following along, hopefully you're all on this page here. I want to walk y'all through what we have here. I want to walk y'all through this portal. You can do a lot of work just in this portal. I should go ahead and point out, if you like Linux and you just want Linux, you're going to go to this clusters tab here, click on ACES shell access, and this will get you your terminal. You're on the login node here, and you can do whatever Linux things you want. If you're not comfortable with Linux, though, a lot of the work that you would otherwise do here, you can still do in the portal. So let's go ahead and walk through what we can do in that portal. So first of all, you're on the supercomputer. How do you manage your files? Again, if you don't want to go the Linux route, you can check out the Files tab up here. Now, I'll talk more about the differences here a little bit later, but you should all have a home directory and a Scratch directory. Your Scratch will be named like Scratch user and then your ACES username, not mine. Let's start off by going to the home directory. Everybody go ahead and follow me. I'll give you all a moment. You should end up on a page that looks like this. I have a bunch of junk in here already from my various years of working on ACES. Yours might be empty, that's fine. But just get to this page for a moment. So this is a fairly standard file browser. So, think of File Explorer in Windows or Finder in Mac. This is like that. You have folders or directories, you have standalone files, etc. You can move and copy and edit things in here. Let me just show you a couple of those in case people aren't familiar with OOD, because this is like a normal file browser. There are some unintuitive eccentricities to my mind, though. So first of all, if you're looking at a blank screen, let's just go ahead and create a new file. We got this new file button up here. Click on that. It'll ask for a file name. I'll title this OOD example file. Make it a TXT. Yeah, TXT. Hit OK. Now, it didn't open a new file. If you scroll down, well, for me, if I scroll down, though, maybe you don't have to scroll if it's your only file, but I now have this file created here. If I click on the file name, I get this blank screen. This is showing me the contents of the file. Well, the thing is, I made the file, but there's nothing in it, hence the blank screen. So I'm going to hit the back arrow in my browser to get back to the OOD file browser. If I want to edit this file, I click on the three dots here to the right, and then you have all these options. Here you click on Edit, and it'll pull up a file editor for you. Then type whatever you want. This is an example file for a short course draft. Put whatever you want in there. Hit the Save button. Now, this file editor did open a new tab, at least in my browser. So this one I will just exit out of once I've saved it. Now I'm back in my file browser. Now, if I click on the file name, there's the stuff I put into it. Okay, then back from there. You might alternatively want to upload a file from your computer. You can do that with the upload button here. Then you can just drag and drop from your local file browser into here, or go through this menu here. I won't walk through all of that just now, but that works mostly the same as any other application does. One thing I do want to show you, because it's, to my mind, kind of unintuitive, is how to copy and move stuff. So first of all, I pointed out a minute ago that we have a home directory and a Scratch directory, right? I clicked on my home directory, and you see over here on the left, there's quick links to home and Scratch. I'm now going to jump to Scratch. And again, I have a bunch of junk in here that you probably won't have. Yours might be empty, that's fine. What I want to do is move that example file I just made in home to my Scratch. So here's how I do that. I'm going to go back to home, to that file I want to move. The way we copy or move it, find the file, click the checkbox over here. Then you're going to go up to this copy move button up here. If you click it, you get this little pop-up here in the top left. This is the part that I kind of find unintuitive. You've selected the file, you hit copy move, and now you've kind of picked it up, and now you're going to move yourself to where you want to drop it and then drop it there. So I picked it up because I have this pop-up up here. I'm going to scroll back up to this quick navigation and click on Scratch. You see, now I've moved my Scratch directory. See the path up here. If I want to put it here now, I will hit copy or move. I'll just hit move here. And now, here's that file in my Scratch directory. Okay. I propose just for practice, in case you're not familiar with OOD, once you have moved an example file of your own to your Scratch, do it again, but copy it back to home. Okay, so Demetrius asked, both home and Scratch are in the login node. We're working in the login node currently, yes. The compute nodes will also have access to them. So like you can pull files, from there for your jobs. But currently, yes, we're modifying both directories from the login nodes. If you're on, like being in the portal, even here, this is on the login node already. You're on the supercomputer. To be clear though, in case you're worried, if you're just on the login node, you're not being charged SUs. So you're not burning access credits here. You're only going to burn access credits when you specifically send jobs off to the compute nodes, and I'll show you how to do that later. If you're just in the file browser and all this basic stuff here, you're not being charged. Okay. I see people have errors, failed to map user. Just to try, those of y'all having the failed to map error, sometimes it's just a cookie problem. Try working in like a private browser or just another browser and see if that lets you log in. If that doesn't work, it's possible that just the account is still working its way through the system and you'll just try again in another couple of minutes. But for now, try another browser or private browser and see if the cookie change will help. I'll go ahead and pause here while y'all log in. Those of y'all who have logged in already, try copying or moving files like I showed you, just so you've done it once. Though, of course, if you prefer to do things in Linux, you're free to do that as well. Demetrius asks, access to the same storage regardless of whether or not we're on the login node or worker node. Yeah, they're shared. Be aware, if you're running a job on the worker nodes and it involves like a lot of reading and writing, that could possibly slow your job down. So oftentimes we'd recommend having your jobs write to the like local temporary space of the worker node itself, and then at the end write everything back to home in Scratch. If it's not doing a whole lot of reading and writing, then you can just work out of home and Scratch directly, because yeah, it does have access. It's just not necessarily the most efficient way to handle files in all cases. What are the size limits of the different storage spaces? I will talk about that in a couple of minutes. For now though, home is smaller but backed up, and Scratch is larger and not backed up. So your usual workflow is going to be to keep all your working files in Scratch and then save your important results back to home when you're done. Let me just show you. You can check your quotas on the Linux command line. I believe mine are defaults. Yeah, so home has the limit of 10 gigs and Scratch has the limit of 1 terabyte. Scratch can be expanded. You'll contact us for that though. In addition to the memory limit, though, be aware of a file count limit. Home is 10K, Scratch is 250K. So for example, if you're going to be installing software, make sure you do it in Scratch, because otherwise you're going to blow out your home space's file quota. I'll talk more about this in a couple slides as well. Yeah, so next let's move on to the Jobs tab. I'm actually not going to say a lot about this. I mentioned earlier that time on the login nodes, you're not being charged access credits. You get charged for jobs on the compute nodes. The jobs tab here is how you're going to set up and manage some of those jobs on the compute nodes. And we'll come back to talk about this later. In particular, these two Drona options. Drona is a thing that we built ourselves. It's a good way to submit and manage jobs. But again, we'll return to that. Next tab is the clusters tab. I showed this already. This is how you get your Linux terminal. We'll use that a little bit later as well. See, next is interactive apps. This is another way to submit jobs to the compute nodes, but this will be how you get graphical user interfaces. So, for example, MATLAB or Jupyter of various flavors, RStudio, you would launch those here. I believe I'll have an example later, but like if you click on one of these, use Jupyter Notebook, for example, it'll give you this form to fill out. And what's on this form will vary by what app you're launching. It'll ask you about environments, nodes, cores, memory, stuff like that. You'll hit launch here, and then it'll, again, send the job to the compute node, but the compute node will also send you back a graphical interface, which is, you know, the point of a Jupyter Notebook, for example. Yeah, we'll come back to this. I have examples later. Related to this interactive apps tab is this My Interactive Sessions tab over here. You know what, I'll just launch an example job just to show you. I don't know what the setup is. It's probably fine though. If I want to launch a Jupyter Notebook, I fill out this menu, I hit the launch button, and then it'll send me to this page here with this box showing me the status of my job. If I were to lose this page, that page was the My Interactive Sessions tab here. See, it's back. So to my mind, interactive apps and My Interactive Sessions are linked. Alas that they're so far apart in the tabs here. But yeah, we'll come back to this a little bit later. For now though, let's finish up with what we can do without burning SUs. Other things in the portal here, affinity groups. This is a place where you can sign up to get more information about ACES or R. I believe these are both access links. Yeah, access. It'll send you to a page like this. You can join in Slack, subscribe for emails, stuff like that. Now, next in my portal, I don't think you'll have this. I have a chatbot that we're working on. I don't think you'll have access to this yet, so I'm going to skip that for now. Next one, though, is important, the dashboard. The dashboard has two options here. This top one, HPC Mosaic, that's the new one. Click on that, and this will show you a summary of what the cluster is up to and what your usage of the cluster is. So, things that are here. We have, excuse me, at the top, we have project information. This is, these are the access credits that you converted into time on the cluster. This will show you how much, or how many service units you have left. I'll talk about service units later. For today, I'm guessing y'all all might just have a single account here. That's the training allocation that you're on. If you set up your own allocation, though, and exchange the credits and whatnot, then that'll appear here. Other things on the dashboard shows you how busy the cluster is. These queues we'll talk about later. These are the, this is essentially the status of the worker nodes working on jobs. So right now you see the CPU nodes are very busy. The GPU nodes, all the nodes are busy, not all the cores actually, etc. We'll talk more about these queues later when we talk about jobs. This is a quick place to show you your quota usage. I showed that on the command line a minute ago, but it'll show you how much of your allocated memory you're using up and how many files you have out of your quota, stuff like that. Shows you for home, for Scratch, and also for project directories, which are related to the projects you have up here. Let's see. Virtual environments, I will show you one of those later, and maybe we'll see it here at that time. User groups, I don't think we're going to mess with these today. Y'all will have a different set here. These are just mine in particular. It's got a little widget for the jobs that are running. Y'all's might be empty. I have that one example job that I just launched a minute ago. When we practice the jobs later, we should come back and check on that as well. Now, the two main things I want to point out here beyond that brief overview is how to get help and how to contact us. So first of all, you can get help rather generically up here with this Get Help button. It'll give you this drop down. From here, you can ask for help with running jobs, account management. This is also where you'd request help with installing software. I'm going to show you later, we do have a lot of software already installed on the cluster, but if you need something new, this is where you'd request it. So click software installation, and then it'll ask you a bunch of details that will help us help you get that software set up. We can help you install either software in your own personal space or possibly cluster-wide, so you can share with your collaborators, something like that. Okay. Similarly, I mentioned earlier, you have file space limits, right, on the file systems, but you can request an extension for Scratch. This is the preferred way to do that down here with this request button. So if I'm working on a big project and I have a billion files, I go down here next to Scratch and hit request, and similar to the help form, it'll ask you some details about your request, and there's some automation in the background that'll send that information to us, and we can work on getting that extension done for you. Okay. That's all I want to say for the dashboard. Are there any questions about what I've covered so far? Dashboard or otherwise. Was everybody able to find the dashboard? This is a good summary to have access to. In case you missed it, that was just the dashboard tab up here, and then either of these. This legacy version has a lot of the same information and functionality. It's just a little bit different interface. The new one is customizable. You can click and drag these to resize them if you want. Only a couple more things to show in the portal here. So that was the dashboard. Next up, this is kind of a special case, but this training menu here has some interactive training. Right now, it's just for the IPU accelerators. I believe we're planning on adding more stuff here, but if you want a sneak peek on that short course that we're going to have later this semester, you can look through this. It'll walk you through running workflows on those IPUs. Fancy. I'm not going to spend much time on this now, but be aware it's here in case you're interested in those accelerators. Next up is the Utilities tab. This is useful for checking the status of the cluster. A lot of these used to just be tools on the command line, but if you're not familiar with Linux, maybe you don't want to go there. We've offloaded them all to this menu here, which is handy. So if you want to see, what CPUs are available, you can click on this and see the status. Indeed, those CPU nodes are very busy. We've only got 2 nodes available to submit jobs right now, as shown in this table on the right here. It also shows the basic configuration here on the left, showing the big picture view of how it's set up. Just to demonstrate, I did mention those were command line tools, so you can in fact just run the CPU avail command on the command line to get that same output. Same sort of thing. Oh, someone ate up those CPUs even. ACES is busy right now. Okay. How about GPUs? We have a similar utility. So yeah, instead of CPU avail, let's go down the menu to GPU avail. It'll show something similar. Again, on the left, this shows the overall setup of the GPUs. So you see here's a node with 4 PVC GPUs, here's one with 4 H100s, here's one with 8 H100s, and then it shows you node by node what they're all up to, how many are available, GPUs and CPUs, etc. And again, this is something you could run on the command line if you prefer to work there. Okay, similar information. Okay. Other things in this utilities menu, you can check on some pre-existing virtual environments that we have available. For licensed software, we have this license status thing here. I'll say this again later, but oftentimes if you're working with licensed software, you're probably just going to want to contact us anyways because licenses are myriad and complicated. Do you need the license? Do we need the license? Does the department need the license, etc.? So oftentimes with licensed software, you're just going to contact us. Final couple things about the portal here. This develop tab, I'm guessing you don't have. I think in theory you can get it. This will let you customize this whole portal thing yourself, but that's beyond the topics of today, so I'm going to skip it for now. If you need help, we got a help tab. This first link will send you to our contact page. If you ever need help, sort of broadly, remember you can submit help requests through the dashboard up here, which will automate a lot of it. You can also generically contact us at help@hprc.tamu.edu. This will go to our help desk, which is people who are routed to people, etc. Let's see what else is here. Online documentation. I believe this goes to our knowledge base. Yeah, okay. And then lastly, restart web server. That's kind of related to the develop tab. If your portal starts acting weird, maybe you'll want to restart. I've never had to do it though, but it's there in case you need it. Okay, and the last thing is log out when you're done. Does what it says on the tin. Okay, so that was kind of brief, but that's the gist of what all can happen in just the portal itself. Later on in the class, I'm going to tell you all about how to do stuff with these interactive apps and how to manage jobs, either on the Linux command line or in the jobs menu here. For now, though, let's go ahead and talk about quotas and service units. So I touched on this briefly before. By default, everybody has two main file spaces that they have access to, their home space and the scratch space. Again, these are their personal spaces, so don't share these with other people. If you want to collaborate, there's other ways to do that. The differences between home and scratch, as I said before, home is a smaller space, but it's backed up. Limits of 10 gigabytes and 10K files. Again, they're backed up. Compare that to scratch, which is a limit of 1 terabyte by default, extensible though, and a file count limit of 250K. And again, scratch is not backed up. So usually do your work in scratch, move it to home when you're done. Now, to be clear, scratch is not like an ephemeral space. Some other sites will clear the scratch spaces pretty regularly, like monthly or weekly or something. We don't do that. If you put stuff in scratch, you don't need to worry about it disappearing as long as your account is active. If we start running out of space on the entire cluster, we will contact people before we delete their stuff, as long as they're active users. Because to be clear, we're not a data storage service. So if you put data on the cluster and then you let your account lapse and don't contact us for a couple of years, then your data is probably gone. Again, as long as you're an active user, it's fine. I've had stuff in my scratch directory for years. Again, as long as you're an active user, we'll contact you before we do anything to the data. The one other space to talk about here, in addition to home and scratch, is the project space. Remember, again, you have an allocation from ACES. Every ACES allocation is going to have a shared group space named after the project entity. This is where you would collaborate with other people on your team. You'd all have your own individual home and scratch that you don't share, but you would all be on this single project directory that your PI has, master access to. To check on your quotas, I showed these briefly before. You can either look at the dashboard, which had those meters showing you what it was, or you can check on the command line with the show quota command. I'll go ahead and show that again. Again, to get the command line, you go to the clusters tab here, then ACES shell access, and it happens to show you your quotas right when you log in anyways, but to say that you've lost it for whatever reason, command is just show quota. And you get that same information back. So home scratch, and again, these are the these are the allocations that I am part of, these shared group spaces. You'll probably have one of these training allocations. I forget which number it is. Now, speaking of those accounts, though, let's talk about service units. So remember back at the beginning, I talked about getting access credits and then exchanging those for time on the clusters. Right now, you're on the login node. You're not being charged anything. When you submit jobs to the compute nodes, though, then you're going to start spending those service units that are tied to those accounts or allocations. One service unit is generally equivalent to 1 core hour on a CPU. You do get charged more if you're using some of the fancy accelerators or if you're using extra memory. For example, if you ask for 1 core but request 2 cores worth of memory, then we have to give you 2 cores anyways, and you get charged for 2 cores. I'll talk more about this when we talk about Slurm later. Let's see, number of SUs you start with depends on which access allocation you've got, and also how much of those allocations you transferred to the given cluster, because you could split them up if you want. SUs are charged on compute nodes, again, not the login nodes, so everything I've shown you so far is all free. You're not charged for it. And you can check your SU balance on both the command line and the portal, specifically in that dashboard. If you want to know more about account management stuff, check out these links to our knowledge base, which will tell you about user interfaces and service units and whatnot. Similar to how there was a command to see the file usage, your file usage, you can also check on your SU usage with this My Project command, or again, check in the dashboard. Let's go ahead and show this on the command line. Just type in My Project. And so we saw before, I have these 3 allocations. Here are those allocations showing which one is my default, financial year they're tied to, the total allocations granted and how many have been used, and then the PI. For comparison, again, if you go back to the dashboard, you should see all that same information. So yeah, my default is this one that ends in 651. Yep, that is my default. That's the one with Hongao Liu as the PI. He's my boss. He has our master allocation. Yeah, that matches. Oh, move that around. So yeah, command line and the dashboard match. That's good. They better. It's the same underlying machinery in both. Good to know. I'm getting all my tabs mixed up. Okay. For reference, I mentioned that an SU is a core hour more if using the accelerators. Here's just a reference table of those accelerators. The Intel Sapphire Rapids / Ice Lake, those are the normal CPU cores. That is, by definition, the 1 core per hour. It gets more expensive as you move on to the accelerators, though. So the PVCs are 30 per hour, jump all the way up to the NVIDIA H100s is 128 an hour. So just be aware of that. If you're using the GPUs, you're going to burn through SUs rather more quickly. Now let's change gears and talk about software. Do you have any questions about the stuff I've covered so far? I mentioned earlier that there is a lot of software on ACES already, but there's also the option to install things if need be. We're going to take those in turn. So if you need software for your workflow, whatever it is, how do you get it? Step 1 is going to be to check and see if we have it installed as a module on ACES already. Step 2, if we don't have it on ACES already, is to see about getting it installed either for yourself in your personal Scratch directory, or possibly with our help, installed system-wide as a module for everybody to use. Let's talk about the modules we have there already. So we have over 940 unique software packages on ACES. We've also got multiple versions of each of those softwares installed, so that we've got a total of over 3,000 modules, that is individual softwares and various versions of them. There's a couple ways to see what all those are. You could go to this link here. So I'll just click it. Yeah, we have this table, searchable table. You could, I'll type in stuff here, look for Python, shows you all the stuff related to Python. I will warn you though that this particular page, this is not directly tied to the cluster. We have to update this manually every so often. There is a more there's a way to get more up-to-date information more quickly, and that will do on the command line. I should just ask, are you familiar with Linux? Have you used it much before? So we're going to do some Linux here. I'll give you all the commands though. So let me know if you get stuck though, and I'll slow down and help as best I can. So the way to get to the modules more directly on the Linux command line is going to be using this module command. When you use the module command, you're going to see that the modules have names, something like this, say toolchain name, or software name, and then version at the end. Let's jump to this. So if you're on the command line, we're going to be using these two commands to start with. These are how you find modules. These are how you find the software that you might want to use. So the first one is module avail. If I go here to my command line and just type that in directly, module avail, this is going to give me a lot of information. All of these are modules that can be loaded right now. There's tool chains, there's specific software at various levels. This is probably too much, even for someone who knows what they're looking for. If you followed me into here and you can't get out, hit the Q key, and you'll get your prompt back down here. More often, someone's going to come in and they know what software they want. They're just going to want to search for it. And they could search on that table page I showed a minute ago, but if you want to be sure to get whatever's most up to date, you can use the module spider command, which is the other thing on this page here. Module spider will look for whatever keyword you give it, and it is case sensitive. So if I do Python again, this module spider, if I do lowercase p Python, it'll find anything that has lowercase p Python in it. So BioPython, Boost Python, it's probably got lowercase Python in the docs somewhere. And even this is probably more information than I need. Hit Q again. If though, I make use of case sensitivity and do module spider capital P Python, this will get me specifically the Python module. And from here, I'll choose whatever versions of these I want and load that up somehow. So how do we do that? What if I want one of these Pythons? The way we're going to manage the modules we want are with these three commands: module list, module load, and module purge. Module list will show you what modules you have loaded up at the moment. Right now, I haven't loaded anything, so it would be blank. The way you actually get one of those modules on the command line is with module load and then module name. And the way you would get rid of it once you're done is with module purge. So in this example here in the screenshot, I'm using this GCC core thing. Let's jump over here and see how that would work. So say I'm coming in, I know I want GCC core. I might do module, to start, module list. No modules loaded, that's correct. I haven't done anything with it yet. Say I know that I want GCC core. Module, let's search, spider, GCC core. Here are the versions. Let's say I want this last version here. I would do module load that module. I've done the command. It didn't give me any output. That's good. That means it worked. If it gave me an error, then something went wrong. Now let's module list again. And it shows me, yes, indeed, I have that module. Say I work with this module, do my workflows. Now I'm done. I would do module purge to get rid of it when I'm done. Module list again, and now it's gone. Now, usually you'll be doing a lot more than just the one module. I believe I have an example of that here in just a moment. Yeah, right here. Okay, so this is a hands-on exercise. You can do this. Say you haven't done Linux before. I believe everything, all these commands, I think you can just put in as they are, though one of them you'll have to edit. Since you're new, though, I'll go ahead and work through this, and you can follow me as you wish. So in this example, we're going to be using this Blast Plus software. Now, I don't actually know what Blast Plus is. This is just the example we have, though. Say that we want to use Blast Plus. let's first find out what Blast Plus options there are. We could do module avail, search through there. There was actually one command I skipped over, this MLA command. This will give us a slightly pared down version. Let's do MLA Blast Plus. Now what this did in the background is it made a new file that will be searchable and show all these results, but we don't need that for now. Mainly, it's shown us these particular versions that are on ACES already. Let's say we can use one of these. Let's just get the latest one. Oops. Latest one. I want to load this. If I do module load.
Just to clarify. So all these modules are already existing on ACES, correct? And it's more we're just accessing them to use the tool and then get rid of it after?
Yes. So, so behind the scenes, and maybe this is too much information, Linux has this, it's got this variable called path. The software is on the system already, but this, but it doesn't know to look in the right places yet. Linux has this variable called path. This stores all the places on the computer that it looks for software. And right now it looks in these couple places. And maybe this looks like gobbledygook. If you find these colons though, those are separating the paths, like the file path that it looks for. And right now, in this example, I'm doing Blast Plus. Blast Plus does not exist in any of these spaces. So in theory, what I would do is go hunt down Blast Plus, hidden wherever we've installed the Blast Plus, and then I would modify this path variable to put it there. The module system handles all that for you, so you don't actually have to mess with all this gobbledygook. If you do module load, and say we wanted this particular software, this particular version, 2.14.1, module load Blast Plus version, if I just execute this, this has an error. A lot of the software has some prerequisite that you need to load first. It was built with some underlying software, and we had to load that up first. Helpfully, it tells us how to find that. Module Spider does double duty. I showed it searching for software earlier, but you can also pass it a specific software, including the version, and it'll tell you how to load it. So let's just execute this, and it tells me I will need to load all modules on any of these lines before that Blast Plus is able to be loaded. So grab, in this case, it's only one line. Some software will have multiple lines here, but I need to load these two modules before Blast Plus. Luckily, though, I believe we can just load them all at once. So module load, just copy those two prerequisites, and then put Blast Plus in there. I believe it can do them all at once. Yes, it can. Okay, so again, no output, that's good, it worked. Now to show you what that did, first of all, like the way you're supposed to handle it is with the modules. That's module list. And now we see we've got 29 modules here, including mainly the Blast Plus that we wanted, but it's also pulled in a bunch of dependencies that we wouldn't have known we needed otherwise. Now I showed you the path variable earlier. It should now be much messier. Yeah, this mess. Back in the day, you might have had to put all your software in your path manually, and we don't want to do this. The module system makes it much better. Because again, your question was, like, it's on the system already, right? The answer is yes. We just have to know where to find it, and we don't want to have to tell it where to find it with all this stuff. The modules handle it for us. I mentioned handling dependencies. Sometimes you might want to try to tweak your setup a bit. So in this case, say we want to roll back to an older GCC version, 10.2.0. The one we used here was 12.3.0. So if we now module load an older version of that prerequisite, 10.2.0, what does it do? It gives us some output that is kind of scary. It tells us we have a bunch of inactive modules, including, importantly, the Blast Plus we wanted. It tells us some things have been reloaded, some things have been reloaded with a version change. At this point, Blast Plus is not usable. The takeaway here is be careful mixing up tool chains, and this is also why you'd want to module purge whenever you're done, because if you move from one project to another, there might be a different set of prerequisites that might make some of your already existing modules not work. At this point, I've made a mess, and I would module purge to get back to clean. See, now no modules loaded, and at this point, I would set up for whatever the next project is, and avoid mixing up all those prerequisites. I believe at this point my path is back to normal as well. Yeah, okay. Does that make sense? If you don't do a lot of Linux, maybe this is also a lot. I hope
that makes sense.
Okay, cool. All right. Let's move on then. Okay, so let's talk about installing software, new software. So that module system is how you would get stuff, is how you'd access things that are already on the cluster. How now would you get new things onto the cluster? If you're familiar with Linux, and you're not, that's fine, but just for future reference, it is possible to install stuff on your own in your own directory, though it depends exactly on the software. Some software maybe you download a binary from their page and then you could upload it using the file menu to your home or scratch space and then use it on the command line. Some of them might ask you to git clone, some might be a Python pip install, etc. So there's a lot of ways that you could get software on the system. I guess long story short, if you need help, contact us. We'll help with whatever it is. If you don't do Linux much, this isn't relevant, but sometimes software will tell you to install using the sudo command on the Linux terminal. You cannot do that. You're not going to break anything if you try it. It'll just tell you you can't do that. Let's see. If you are installing yourself, watch your scratch space. Watch your file quotas install in scratch space, because that's the bigger area. If you try to install in home, then you're going to blow up your file quota. If you want to install software cluster-wide, contact us. We can do that for you. So say you're in a research group and you all need this particular software. If it's not on the cluster, ask us to install it cluster-wide so then your whole group can use it and not just one person. And again, you can request that kind of thing from the dashboard. It had that under the help menu, it had a software subsection. And lastly, I mentioned before, if you're using licensed software, like MATLAB, I think, for example, with licensed software, contact us. We have some licenses ourselves. Some other software, it might be you need the license or your department needs the license. And there's rules on who all can use it, etc. So just contact us in that case. This next bit is how to manage software in Python. This is all going to be command line stuff, though. And if you're not familiar, this may not be useful at this time. I'll just talk about this briefly. I'll walk through it myself. If this doesn't make sense to you, though, that's fine. It's not super important at this time.
I think I'll be okay. I think I'm realizing I do know, I guess, more than I thought I did.
Okay, that's good. Well, let me know if you have questions along the way. So Python, though, and Python virtual environments. Python's a fairly popular programming language, and it's also very extensible. There's a lot of external things you can bring in to add on to it. And one way you do that without messing up like the central file system is by using virtual environments. For a given project, you'll set up a virtual environment, install everything in just that virtual environment, and then it'll be isolated away from other projects, for example. So let's do an example of that. On the command line, let's see. I think you can do this from anywhere. Out of habit, though, I'm going to go to my Scratch directory. I think you can do it in home, though. So here's my Scratch directory. There's a bunch of junk in there already. Don't worry about that. We are going to work through these steps here. First of all, we module purge. ML is shorthand for the module commands. I believe I module purged already. I'm going to list just to check. Yeah, okay. So I'm starting clean. We're going to use this create VM command. Now, this is actually specific to HPRC. This command is something we set up ourselves. If you're doing plain virtual environment setup, there's other commands that I never remember. I like this, so I'm gonna, well, let me copy, no, hold on. I gotta pop out of presentation view. I'm just gonna copy all this real quick and paste it into my command line. Now what this is gonna do, so create venv, as I mentioned, this is a tool that we came up with ourselves. We're going to create an environment named, in this case, myenv. This could be anything, it's just a name. We can add a description of it with the -d flag. In this case, it'll just be example environment. And then we can specify what underlying modules we want under it, in particular the Python version, because we're going to be setting up a Python virtual environment, right? We probably want a particular version. In this case, we wanted Python 3.13.5, and we have this GCC core in there because that's one of the prerequisites for loading the Python module. If you were using a different Python version, you'd probably have a different GCC core. Let's just run with this for now. And you know what? Be careful if you also copy paste from the slides, because I think I put in special quotes there instead of normal quotes. You know what? I didn't show you. These slides that I'm showing, by the way, you can find those on the course webpage. Same place you registered. Down here, we've now got a link to the PDF. So if you want to refer back to these slides, they're available here, and you can copy paste stuff out just for future reference. If you do copy paste, though, again, watch for special characters. Actually, let me show you the problem with that. So I copied from the slides. You see how these first two quotes are like straight up and down, and these second two quotes are curved and fancy? If I try to run this now, I get this error. It didn't like it. That's because of those quotes. It's some other special character that the command line doesn't like. So if I fix those, you get output like this. Okay. It was created successfully. To activate, we use this source activate venv and then name command. Let's just go ahead and do that. Source activate venv inv. Okay. Oh. Did I do it wrong? What happened? Something went wrong. Sorry, give me just a moment to troubleshoot. Oh, what happened there? It didn't actually create it. Oh, I skipped over it. What happened here? It had an error.
I think I noticed I got that too.
Same thing? Okay. What does list end show? Core dumped. Oh, that's not good. Okay. So as I said, that create venv tool is something that we made ourselves. I wonder if they're still messing with it and then they mess something up. Give me just a moment. I'm going to point them to that. See if I can make them fix it. At least they know. We have a knowledge base page about how to use these tools. If you want to check back on that later. Show you that. The name they came up with is a modulator. So yeah, once I get that fixed again, check back here. Shows you examples of how to create and edit virtual environments. And alas, I've been working with that tool for so long, I don't remember the syntax for how to do it with Python normally. So that's embarrassing. So broadly, what would happen if you're doing Python environments? You'd create the environment one way or another, either with this tool that's not working or with the usual Python methods. I believe there's a command that's just called like virtual env or venv, but I've not used it for a while. Once you do create one though, using it would look something like this. You'd run it to activate script. Here we go, yeah. And then once you're in a virtual environment, you'll see that it modifies, your command prompt. So ahead of this base one, I now have this thing in parentheses. That's the name of the environment that I loaded up. And then if I were to install some Python programs using like pip or something, it would be installed just for this environment, like contained inside this particular directory. Let me see. So if I run Python, actually, just to demonstrate. So if I get out of that environment, say I'm starting from blank here, we do have Python here. And if I try to run some Python stuff, this should fail, I believe. Well, I expected it to fail a different way. You know what? Hold on. Let me restart my terminal. Maybe my terminal's just messed up from messing with the modules earlier. Okay, that's more what I expected. You know what? Maybe that's the problem with. Maybe that was the problem with our tool. It was just picking up other stuff I did earlier. I'm going to try this again. Fix the quotes. I might still have the one that I did messed up earlier. And I just made a mess earlier. Okay, try it again. Create the environments. Okay, that looks good. Okay, that might have worked. All right. Okay. The problem I think was that it still had stuff hanging out from when I was loading and unloading modules earlier. This is why you module purge, and perhaps just restart your shell to make sure nothing old is interfering with something new. Okay. So let's try this example again. So we made this environment. We have this list VMs option to show you the environments that you have made with this tool. Here's the new one I just made. Indeed, shows me the versions we made. Cool, cool. Now we haven't activated it yet. We're going to source, activate venv, and the name of the environment. Venv, my-env. And now similar to what I had, yeah, there it is. Similar to what I showed you with that CUDA-Q environment I had earlier, it's now modified my prompt to show the name of the environment here. So now we're inside the environment, and whenever we pip install stuff, it'll just be in this environment. So example here I think was PyTime. Yeah, let's try this. Right now we haven't installed anything in the environment. We've just made this container and it's kind of empty. So if we do, let's first check what Python we have. Okay, it's using this particular Python found inside this virtual environment. That's good. If I try to run a Python command, this is going to tell me it doesn't work. Okay, and this is a Python error. This is what I expected. It doesn't know what PyTime is. That's because we haven't installed it yet. Now, though, inside the virtual environment, we can just install it for ourselves. So what we're going to do is pip install, I forget the name, it's not PyTime. Yeah, Python-time, that's it. Python-time. Okay, and it's downloaded the stuff specifically to this virtual environment. That is, it's not going to mess with anything outside of this Python environment. So if we run this Python command again, okay, no output, that worked. We didn't tell it to give us output, so now let's tell it to do something. Let's just print where that new PyTime thing is. Okay, module PyTime from that particular virtual environment downloaded somewhere in there. So now, if we deactivate, so now we're outside the environment. See, that little preamble has gone away. I'm also going to module purge just to be safe. Now, if we try to do that Python stuff again, it doesn't even know where Python is, because now we're outside of that environment where it had all the setup for us. So this is good though. Like when you work on a project, because of the possibility of software interfering with one another, you want to put them in these environments that are like separate from one another. So the fact that we only have PyTime and Python inside that virtual environment and we don't outside, that's good. It means nothing in the environment is going to be messing with other stuff, so we're free to move on to other projects. Okay, I think that was all here. Yeah. Any questions on that?
No.
Okay, cool. And I see Mohammed's joined us. Thank you for joining. If you'd like, we can get you logged into ACES to follow along with us for the last couple of exercises. Let me share with you the slides if you want to catch back up. If you go to this webpage here, near the bottom left here, this PDF is the slides that I'm showing, and it'll show you some of the setup instructions. Back on slides, like, where was it? Yeah, slide 9 and 10. That'll get you logged into ACES. I was going to say something else. I forget now. Actually, we're about to move on to another topic. How about we go ahead and take another 10-minute break? That'll give Mohammed time to log in if he wants, and otherwise, time for us to reset to a different topic. So yeah, for the final stretch here, let's talk about how to finally spend those access credits and do some supercomputing on the compute nodes. So here's a little cartoon overview of what happens here. Remember what I said earlier, the sort of like 3 layers of computers involved in working on our clusters, right? You have the user's computer, you have the login nodes on the cluster, and then the compute nodes on the cluster. Generally, you're going to be writing instructions for whatever workflow you want on the login node, and you're going to pass them off to the compute node somehow. The way we do that is with this software called Slurm. You're going to write instructions on the command node, give it to Slurm, and Slurm is going to be pulling everybody work on the cluster. It's going to be pulling instructions from all of them and pass off their workflows in an orderly manner to Slurm. So how do you give instructions to Slurm? A basic Slurm job script is going to look something like this. If you're familiar with Linux and Bash scripting, this will mostly look familiar. It is, in essence, a Bash script. You've got your shebang at the top, and then a bunch of Linux commands at the bottom. What's new here, what makes it Slurm, is this sort of a Slurm preamble here with all these sbash lines. Now, they start with the pound sign. So to Bash, they just look like comments. Slurm knows they're not comments, though. It is specifically looking for these lines. You have to have some of these. These sbatch parameters are providing details about what resources you need for your job. For example, number of tasks per node, number of tasks, number of nodes. There's other commands for like number of cores, for or down here the memory or the time, for instance. The job will have to know how long it needs to run, or else Slurm will not accept it. You can also provide a job name that will show up to help you identify the output files, for example. Again, though, once you have all this, it's just normal Linux commands down here, like you would run on the command line. The difference is if you run these directly on the command line, the login node may not be big enough to run them, and it'll get mad at you and kick you off, and your workflow won't run. So let's do an example with some example job scripts that we've made already. What we're going to do, so we're going to write our job script or edit a job script, and we're going to submit it to Slurm using the sbatch command. If we've submitted the job successfully, it'll give us output like this, at which point we can check on what it's doing with SQ, like this, to show what nodes it's running on, how long it's been running, stuff like that. So let's do our example here. We have provided examples for you on ACES already. You can copy it using these commands up here. Let me get a shell back. Put this out, and we're going to copy from scratch training Slurm example, and we're just going to put this into our scratch space. These files are small enough you could probably run in home as well, but just get in the habit of putting things in scratch because that's a better workspace. Oh, and it's a directory as well, so I'll have to make this copy recursive. All right. So let's now go to scratch and find the thing we just copied. Demetrios, I see you just came back. I'm talking about Slurm now, if you'd like to join me. I forget if I showed you when you were here. The slides I'm showing, if you want to catch back up, you can find those on the course webpage. The link down here, this PDF. I'll send you the link here. Another meeting, okay. This is the problem with multi-hour short courses. A lot of people have meetings on the hour. You have the slides, okay, cool. So right now I'm down at the final section around slide 50-ish. I should ask, are you familiar with Slurm already? A bit? Okay. So this is just a simple example here. We've got a example Slurm script, if you want to follow along, doing this thing here. So example Slurm script is at this path here, scratch training Slurm example. I've just put it in scratch, and now I'm just going to go there myself and launch it, just for example. So inside that Slurm example directory, there's a job file and a py file. What are they doing? If I go into the job file, it looks like the example I had on back on one of the earlier slides. Here on the bottom, I've got a bunch of commands that I could otherwise run just on the command line. At the top is the shebang, like a bash script, and then in the middle is a bunch of information for the Slurm scheduler. So this job is just going to be named Hello World. It'll have a time limit of 15 minutes. It's not going to take that long. One single task, one task per node, one node, 3 gigs of memory. It's not going to need that. And we're going to look for an output file at the end named hello world log dot something. %J is code to Slurm to put in the job ID there. So we'll have some number in our file at the end. Now, what is the job doing? It's doing some environment setup, module purge, load GCC core and Python, and we need Python to run this final Python script. That was also in our directory. What is it doing? Hello world.py. It's just going to sleep for 30 seconds so we can check it in the Slurm queue and then print out this line here. Final thing that the job was going to do was just print out some of these environment variables here for reference. So to submit it, we do sbatch and then the name of the job file. Okay. It says submitted batch job. Question, how do we set the job script to write output in scratch instead of home? This is going to, it's going to write it right here actually. once the job starts. If you wanted to be sure about it, though, I think you can just provide the full path in the name here. So you'll have dash dash output equals and then full path. Right now, I think it's otherwise just going to put this like where you launched the job from, or where the script is. You know, that's something I can check even. So the job script. Oh, so here's my output file, hello world log, and then job ID. Actually, before it ends, really quick, if I do sq-sme, it shows you you're running Slurm jobs. This top one is that interactive app I launched back at the beginning of class. The second one, name hello world. This is the job script that we just launched. It's running about 36 seconds, which tells me it should be about done because we just made it sleep for 30. If I run SQ again, still going longer than I thought. Okay, thinking about it. It's writing to this output directory. Once it's done, it should be any minute now. There it is, okay. Fell out of the Slurm queue. So now we can check on that log file. And here indeed are the things I told it to print out. Here's the thing from the Python script, and here's the environment variables that we had in the job script. Just to check now, to see where the output file goes, if I launch it from, I'll just go to my home directory. I can launch that job file from here. Fat scratch slurm example hello world.job. Submitted the job. It's now running. Or no, sorry, it's pending. If you check really quick, it might be pending even if it's not really. There we go. Now it's running. And I believe this is it. So it's, yeah, wherever you launched the job from. That was here, yes. 20th, yeah, that's now. Okay, so here's the job file that I launched from here. If you wanted to specify it be somewhere else, you just put the full path in that argument. Okay, it finished. Check the log. Oh, and tried to run a file that's somewhere else. That's my fault. So to write to scratch, yeah, you'd cd to where you want to launch it from and launch it from there, yes. Just to check though, it might be better practice anyways to put a full path in there anyways. So if I change this to, I'll make a new directory here for it. If you're doing a big complicated workflow, it might be good practice to have a separate logs directory anyways. So if I did this full path, and then I will append that logs directory at the end of it. Okay, and we'll launch it one more time. Check what it's doing. Pending because I just started it. Oh, come on. I'm impatient. Okay, now it's running. I still have the old log file here, but now in the logs directory, there's the new one. Okay, yes. So that's probably the best way to do it. It is just give it the absolute path for that argument in the Slurm directive. Yeah, set the path in the job script, and then it'll go wherever you tell it, and not just wherever you happen to have launched it from. Best practice is probably to give it the full path. That way your job script is portable. Although, I suppose the issue is whether or not you're sharing the job script. Because if you direct the output to a space in your own Scratch space, then someone else couldn't run it. Maybe I'm splitting hairs at that point though. Yeah, probably give it the full path in the job script so you know for certain where it goes. And then if you share the job script with someone else, just tell them, hey, you'll have to change this. The best code is self-documenting code, and absolute paths kind of help with that because then you know exactly where it's going no matter where it is. So yeah, I'd say full paths is best practice. I'm willing to allow some wiggle room depending on your exact workflow in your group or whatever though. Okay. That job finished. Check the log. Yeah, it worked. Cool. I suppose we saw one other benefit to absolute paths a minute ago. Remember when I ran this job in my home directory and it couldn't find the Python file? Because of that, it might have been better practice even to specify a full path for this in addition to the log file. Okay. I think that's all I had for this example. Yeah. Any other questions on that? A couple more utilities we have to see what the cluster is doing, and so see what kind of jobs you could possibly get away with running at this time, because this is the shared cluster, right? So not all the resources are always available. Ways to check what's available for jobs. First of all is sinfo. sinfo will show you a breakdown of the Slurm queues that we have. So the resources that are on the cluster that Slurm is managing, they're broken up into basically like lines that you would wait in a queue. If you want a GPU, you wait in the GPU queue. If you just want a CPU, you wait in the CPU queue. If you want the FPGA, you're in the, in this case, the bitware FPGA queue. And sinfo will show you what those queues are doing right now. So back on my command line, just type in sinfo. And there's options you can give it to tailor the output, but usually sinfo by itself is most all that I need. So it shows you for each of the partitions. Is it up? They're all up. That's good. Shows you the time limit. The syntax here is days dash hours, minutes, seconds. So the CPU queue has a time limit of 3 days, whereas GPU is 2 days. And GPU debug is 2 hours, for example. Shows you the job size. And last part is the actual status of the nodes right now. So both the nodes and CPUs here, they both have sort of hastily thrown together columns A, I, O, and T corresponding to these numbers here. Those correspond to active, idle, offline, and total. So if we're looking at the CPUs, for instance, we see in the CPU queue, there are over 6,000 CPUs that are currently active. There's 580 that are idle. That is 580 that are available for your job right now, if you were to submit one. We got 288 offline. That's probably like down for maintenance or something. And then total, just, some of them. And then we have this, again, for each of the queues for all of their resources. So this is a good way to get a quick picture of how busy the queues are. This is possibly in addition to checking out the dashboard, which recall should show something similar. I think we saw earlier, the dashboard shows that a lot of CPUs were in use, right? Yeah, CPUs are getting used a whole lot right now, agreeing with what we have up here. Tons of them being used, relatively small amount idle. Okay, so that is the queue level look. We can now move on to PEstat to give us a node level look. This will give us a big list of what all the individual compute nodes are doing. So let's just show that. Now, this is a lot. Probably you didn't actually want to know what every single node was up to. You were probably just looking for some specific one, maybe. And we can do that, as it shows on the slide here, by specifying some options. So, for example, with -P, we can give it a particular partition name. So as shown in this screenshot, if you want the GPUs, you just want to check on the GPU queue. So -P GPU, and then this extra -G option will show you the status of the GPUs in particular. And you can even see who all is running jobs on a given node. So like you see that in the screenshot, this 8 H100 node is very busy. Got a lot of people on it, for example. We can just run that here to see how it's going. -p GPU. Okay, not quite as many. Well, still a fair amount in use. We've only got one free GPU, but that one's drained. Again, probably for maintenance or something. The rest of these all still get used a fair bit. You see I don't have the extras here that were in that screenshot. That's because I didn't have the -g option. You just add that to get these, I think it's generic resources is what GRES stands for. Shows you how they're configured. So 2 A30s, 8 H100s, for instance. The last tool I'm going to show you here is maxconfig, which is very useful for checking what resources you can put in your jobs. That is in your like Slurm preamble. If you just run maxconfig by itself, it will show you by default the limits for the CPU queue, and in particular for one node. You can actually go beyond these limits if your software allows for multi-node, but this is the limit per node. We saw earlier that the time limit for the CPU queue was 3 days. We see that again here, so don't go above this in your Slurm script. I guess speaking of, if you ever forget what the what the required Slurm limits are, you can just do maxconfig and copy this chunk here. This will get you most of them, if not all. Maxconfig also shows you like maximum number of SUs you can use. In particular, though, it will also give you an estimate of SUs for a job script that you give it. So those example job scripts that I was using, this tiny hello world thing, I can do maxconfig -f for file and give it that job script, and it'll calculate for me how many SUs it'll use. Now, this was a tiny job script, and it's only going to use 0.25 SUs. Just for example, I can bump up what I'm asking for to show that calculation change. Let's say we want, 20 hours or something. Now run it, and you see, yeah, it's about 20 hours, and then the 25 for the 15 minutes or whatever. It is very useful, yes. Good to know beforehand. Now, I should say as well, this is like the maximum SU use that it will use up if it spends that whole time. If your job finishes early, you'll get some of the SUs refunded back to you as well. I guess to be specific, when you submit the job, it'll deduct the full amount of SUs, like this amount, from your account, but then it'll get refunded if it ends early. So you can calculate resource usage beforehand. Yeah, that's what this tool is supposed to do. My memory is that once upon a time, it had trouble with GPU calculations. I think that should have been fixed, though. We fixed it when we saw it. If I switch this to, yeah, let me check, in fact, maxconfig partition GPU. Now that I've specified it, it gives me some GPU specific stuff. So you see you got a different maximum SU usage, different time. If I were to, I'll just copy this stuff. Put that in my job file. Okay, I won't necessarily do the maximum amount. What about like 2 hours on the GPU queue? Oops. 2 CPUs for task. Let's drop down the memory bunch so that the main determinant is the GPUs I'm using. How about the H100s? Let's just get 2 of them. Yeah, let's see what that does. Maxconfig -f hello world.job. 518 SUs. Okay. again, the GPUs use up it's used much more quickly. Does it work well in different cases? Can it account for jobs requiring multiple threads? So you can, so the resources that the job uses up. So Slurm cannot know beforehand what resources you're actually going to use. The stuff that you ask for in here is sort of the maximum. So you're requesting an upper time limit and an upper memory limit. So does it work well for different cases? Max config is not going to know that because Slurm can't know that. You would have to do some estimating yourself, and then like probably ask for a little bit more than the amount you need. Actually, yeah, let me talk about that. So I mentioned you get some SUs refunded, right? A lot of users have the instinct to request like a very like tight amount of time or memory because they don't want to be charged more. And oftentimes their job goes right up to that very tight limit. And then if they see it starts to go over, they contact us in a panic asking us to, extend their job time or something. And sometimes we can do that, but we don't promise that. That's a courtesy we offer when we can. Best practice is usually going to be to ask for like a little bit more than you need. Because if your job starts going over the amount you actually think it'll hit, well, that's fine. You've got this buffer zone. And then whatever it doesn't use will get automatically refunded to you once the job is done. So asking for a little bit more and getting refunded is better than asking for not quite enough and then the whole job failing. Now you asked about OpenMP and MPI. I'm unfamiliar. I mean, I know what they are. I'm unfamiliar with how well Slurm can account for those. I think it's the same situation. If you're doing like OpenMP or OpenMPI, you'd probably be asking for like multiple nodes or something. And you can do that in Slurm. It would get, okay, I guess in that sense, max config would still work because again, it's just going off of the Slurm directives that you give it. If you ask for more resources, I'm unfamiliar with fair share. What's that? Is that a cluster management thing? Do you mean priority in queue? Okay. I'm not aware that we have priority really at this time. As far as I'm aware, it's just, first come, first serve, like for the given resources. Oh, actually, you know what? I don't know if you have time today, but our short course this afternoon, my colleague Michael Dickens, that short course is all about Slurm. So you might want to ask Michael because he might know more about some of these details than me. He might know about MPI and fair share. He'll have a lot more to say about Slurm than me. We're actually running kind of low on time in this short course now. How much more do we have? A few things. Let me show you these last couple things really quickly. Again, if you want to know more about Slurm, you can either attend Michael's class in the afternoon or just contact us sometime. We'll help you whenever we can. Final couple things here. So the tools I just showed you are good for determining what jobs you can do before you submit them. After you submit the job, though, this My Job command will show you details of your completed job. So let's see, if I grab this job ID here, because My Job by itself, it'll ask you for the job ID and give you this help message here. Give it the job ID though, and it will tell you how good the job did. So did it complete? What is this memory efficiency? How long did it run? Submit directory, stuff like that. Typing that will show fair share. Let's have a look. I'm unfamiliar. I see. Well, good to know. Again, I'm unfamiliar with this myself, though, so ask Michael if you want to know details about how or if we make use of this. That's otherwise a part of Slurm I've not gotten into much. Final couple of things about submitting jobs. So all the Slurm stuff we just did was on the command line. We do have some non-command line options as well. That's the stuff I hinted at earlier, back here in the Jobs tab. So in particular, this Drona stuff, this workflow engine, this is something we've been working on to hopefully make it easier for people to submit jobs, even if they don't do stuff on Linux very much. I assume this is just our dev version. I think the other one might be the same. But, yeah. Okay, so Drona looks like this. What you can do here is do a lot of the stuff that you would do in Slurm, but you can fill it out in the menu here instead of having to remember the Slurm directives. What's neat about this, though, as well, is that the menu stuff here, it's all configurable and changeable. So let's see. If I choose this generic environment, you see the form's updated. And now it's asking for a lot of similar stuff that we'd have had to give Slurm in our job script. So number of tasks, the accelerators you want, total memory, etc. And this changes depending on what kind of workflow you choose here. So MATLAB has something different. Give it a main script, parallel processing workers, stuff like that. Users can also modify this and create custom environments, though. So if you have, a given workflow for your research group to work with, and not everybody knows how to do Slurm, you can set up your own environment here that'll have its own custom form that your users can just fill out here and submit a job from here. Really quick, let me show you just what that looks like and the time we have left. Test job, I'm going to leave a lot of this default. Once you filled out the form, you hit preview, and it'll just tell you the Slurm file that it's going to submit, and you can even change this from here. So, say I had a Python script to run. I don't have one at the moment, but you would touch up this as you'd like. It shows you the way it's going to run it with this driver script, and then you just submit job. It'll tell you if it was submitted successfully. We can close out of this. It'll show you the job history from which you can rerun or recreate a given job you submitted, stuff like that. It is 12:30, which is technically the end of the class. Let me check real quick how much more there was. I should say as well, we do have a Drona short course later this semester as well, if you want to know more about that, and if you want to see how to edit that menu, like I mentioned. Alternative to making a job script to Slurm. Yes, it can do that, but also some other workflow editing stuff, again, with the custom menus. Again, when you first come to it, yeah, it's a good alternative to Slurm, but check out that other short course for more details on the stuff you can do with it. Let's see. This is all the stuff I flew through. The one other option for submitting jobs is Tamu Launcher, and I'm pretty sure Michael's going to talk about this in the afternoon if you want to know more about this. This is a more robust and efficient way to submit array jobs. So if you're submitting a batch of 100 jobs at once for whatever reason, this is a way to dynamically release resources once a given job is done, for instance. Basically, you'd create a command file with a bunch of things you want to run, and then Tamu Launcher will gradually work through that. It'll checkpoint itself, and again, release resources once it's done. So it's very cluster friendly. Final couple things, you should be aware of Globus. This is the best way to transfer large amounts of data, and this is not jobs at this point, by the way. Remember at the beginning I showed in the portal file browser, you can upload and download files. There's kind of a size limit to that, beyond which it'll start getting slow and bad. Globus is a good way to move large files quickly and reliably. ACES has a dedicated node for this. You would search in the collection up here for access Tamu ACES DTN, and then transfer that to some other endpoints. Okay, we're out of time. This final section, in case you're interested, this gives a couple more details about the fancy stuff on ACES. It tells you how to make use of composability. In short, it is just contact our sysadmins. They'll compose whatever node you want. Details about the accelerators. Most of them are in Slurm, as you see here. These final couple slides tell you how to access all of them, the GPUs of various flavors, the IPUs, composing memory. There's a couple slides at the end showing like the hardware setup of ACES, but I'm not going to bother with those for now. If you want to know more about the ACES configuration, check out the knowledge base. It's got more information there. If you need help, feel free to contact us either through the dashboard or through our email. Kind of crunch for time at the end there, so sorry for that, but that's about all I have for you. If you have time, please fill out our survey to let us know what you thought of the course. And otherwise, thank you, and we hope to see you for future short courses. I forget if I mentioned before yet, this recording will be on our YouTube channel eventually. There is some processing time though. There are older versions of this course already on the channel though, if you want to see it sooner. Feel free to contact us if you have any questions.